Curious Tales of Chemical Compounds.
This week, Sam Tracy introduces a cleaning compound with real bite.
If cleanliness is next to godliness, then most of us are downright ungodly. As long as it's not smelly and won't kill us, that's usually good enough. If you disagree, I need only point out that a large proportion of the cells in your body are alien organisms that got there because, frankly, you don't really care what filth you come into contact with. Good chemists, on the other hand, have higher standards. For them, a smear on their test tube is a smear on their reputation. They are all too aware that a purity of 99.9% is just another way of describing an impure substance, and purity is the measure by which they will be judged. Thus, they have developed a whole range of solutions for cleaning their glassware. But few of these are designed with the intention of being soft and gentle on the hands. As its name suggests, one example, Piranha Solution, is a cleaning solution with a bite. It might be named for the fact that it eats all organic matter it comes into contact with. Or perhaps it's because of its propensity to boil vigorously when it reacts with organic matter, or even while it is being prepared, causing it to resemble the piranha feeding frenzies depicted in horror movies. Either scenario should serve as a warning to anyone who might dare to use it. It is a mixture of concentrated sulfuric acid and hydrogen peroxide solution, usually in a ratio of 3:1. Mixing the components produces large amounts of heat, and doing it in the wrong order or in the wrong ratio can cause explosion. Letting it come into contact with organic matter can cause explosions. Leaving it unattended can cause explosions. Looking at it disapprovingly or slagging it off to your mates down the pub can probably cause explosions. You get the idea. It's temperamental stuff. These warnings are not just hyperbole. This extract from a report of an accident at a lab in the United States holds testimony.
A row of glass cabinets along one wall were peppered with holes from the shrapnel. A glass drain pipe on one wall opposite the fume cupboard, about 8 to 10 metres away, was cracked in the middle. It is believed that it wasn't caused by shrapnel, but by the compression wave of the blast. A student had been wearing rubber gloves, a thick sweater, a lab coat, an apron, and safety glasses at the time of the explosion. The fume cupboard sash was partially down and absorbed some of the blast, preventing the student from catching all of it in the face. The arm holding the sinter funnel received most of the damage. The glove was completely flayed, and their arm had several hundred small bits of glass embedded in it, as well as several fairly large lacerations. They had a wound about 20 millimeters in diameter just next to their jugular vein. At least one piece of glass went through their cheek. The student, and everything else, was also covered with hydrogen peroxide and sulfuric acid, something that wasn't realised until much later because those first on the scene had no way of knowing what had happened. The student spent the next 6 hours having tiny bits of glass picked out of their arm, neck and face.
Piranha Solution works by combining the dehydrating power of concentrated sulfuric acid and the oxidizing power of hydrogen peroxide. The former effect should be familiar to any schoolchild with a chemistry teacher worth their salt. They should have seen their teacher add concentrated sulfuric acid to a beaker containing sugar. After a short while, the sugar will start to turn brown and steam will start rising from the beaker. Eventually, the reaction will accelerate and the sugar will expand into a tower of black carbon, accompanied by a pleasant aroma of overcooked cake. In this reaction, the sugar, with formula C6H12O6, undergoes a dehydration reaction, losing atoms of hydrogen and oxygen in the ratio of 2:1 in the form of water, H2O. The role of sulfuric acid is twofold. Its acidity catalyzes the reaction, and being a hygroscopic substance, it combines with the water, releasing a great quantity of heat, meaning the reaction cannot go in the reverse direction and can only proceed to completion. This reaction would make sulfuric acid alone an unsatisfactory cleaning agent, since it would leave all of one's glassware caked in carbon. The role of hydrogen peroxide, H2O2, is to get rid of this carbon, and it achieves this because it is an oxidizing agent. It will readily give up one of its oxygens to the carbon, producing carbon dioxide. So if it were added to sugar alone with concentrated sulfuric acid, it would leave nothing in the beaker. Even any water produced would evaporate as steam. However, adding it to such a large amount of organic substance is unwise, as it would likely react explosively. But to remove the last bits of residue that will only depart reluctantly, the mixture of sulfuric acid and hydrogen peroxide is perfect. Glass is not the only thing it cleans. Piranha's solution is also used in the electronics industry to clean the photoresist residue of silicon wafers during the manufacture of printed circuit boards. It's possible the device you're listening to this podcast on was treated with it. So next time you have a wash, bear in mind the poor chemists who have to go one step further with their cleaning product, braving the threat of ferocious waters, that they might achieve the cleanliness that the rest of us can only dream of.